In this video, we'll complete this control flow extension of the build your own interpreter challenge, and we will do that by implementing while statements, for statements. Not only that, if you go into the book that this challenge is built upon, the Crafting Interpreters book, the author has challenged you to add break and continue statements. We will do that as well. That's not part of the CodeCrafters challenge, but we will do it nonetheless. So to do that, we first of all need to make changes to our context-free grammar. Uh, so this is what a grammar looks like right now. And the last thing we added were logical or and operators. We need to add for statements, while statements, break statements, and continue statements. So let me add that. And loops, going to be loops, breaks, and continues. So for and while are actually statements, so are continue and break. So we will add them to the statement. We have while statement, we have for statement, we have break and continue as well. Break is STMT, and continue STMT. So we need to add all these while, for, break, and continue to our language. Let me copy them. While, for, break, and continue. So the easiest things to add are the break and the continue, so we will do that first. And all it is just the break keyword and then a semicolon. So break followed by a semicolon. Similarly, continue is also just continue and a semicolon. Continue and a semicolon. A while is a bit different. So a while statement is essentially just the while keyword. The while keyword is then followed by opening parentheses, and between the opening and closing parentheses we're going to have an expression. That expression evaluates to a truthy or a falsy, and after that, after a while block, it may have an expression statement or it may be followed by a block. It may also be a print statement and maybe a nested while loop. So all of those are handled by statement, like so. The grammar for a for loop looks a bit daunting, and parsing a for loop is also going to be a bit daunting, but interpretation is not, because for is essentially syntactic sugar over a while loop. As soon as we have any looping construct, all other loops are just a wrapper over those looping constructs. So a while loop is easy to interpret. So we will, when we parse a for loop, we will convert it into a while loop. I'll show you that. But the grammar for a for loop looks like this. It also has opening parentheses and closing parentheses, but in between the opening and closing parentheses, we have three things. Those things are, the first thing in between the parentheses may be a variable declaration. So it may be a var decl, but it's possible that the variable was declared previously and we are just giving it a value. So that will be an expression statement, and it is possible that we do not give the variable any value. It may be declared previously, and we will just be using it in our for loop. So it's possible to leave this part empty as well. In that case, it will be a simple semicolon. Now after this, the first thing will be one of these three things. After this, we will have an expression, and that expression also evaluates to a true or false. It's essentially the same thing as this expression, but it is also optional in a for loop. It may just be a semicolon. The expression in a for loop is optional, and after that, again, we are going to have an expression. Now this expression is what we typically use to increment or decrement our iterators, and again, it is optional. It's not necessary to have this expression right here. So a for loop can look like, I hope you guys know this already, this is a valid for loop. So this grammar handles all those cases, and by the same logic, by the logic that we have a statement here, the same logic applies for a for loop as well, and we can have a simple statement here. So that will be the changes to our context-free grammar. Now we need to add these to our AST when we are parsing them. So we created four things. We created a while loop, we created a for, we created a break, and we created a statement. Now, like I told you, uh, when we parse a for loop, we will convert it into a while loop. So let me not add a for, let me just add a while, and when parsing it, we'll create an object of while instead. But we do need objects of breaks and continues. So let me first create a while. Let me handle while first. So while, and it must extend statement. And we need to implement the methods, and visitor dot visit, and it will be a while statement, and we will pass it this. What else does a while loop have? A while loop has an expression. If you were to look at its grammar, it has an expression and it has a statement inside of it. Now the statement may be a block. Like I told you earlier, we created a block which we reused in an if. Similarly, we're going to have a block which we will use in a while. So we have an expression here, public final expression, and this will be the condition of our loop. Let's import it. Condition and public final statement, which will be the body of the loop. And while parsing the while loop, we will actually use the block for the body instead. So let me create a constructor for it. We need to parse it. So let us do that. We added it to our statement rule. So let's go to statement. Here it is. Statement. So go to statement. Yeah. So in our statement, we are checking for some keywords, and based on those keywords, we parse what's following it. So we are parsing print statements, if statements, and similarly we're going to pass a while statement. And instead of if, we will call while, and let's create this method. In this method, this current token method, it consumes the token that we are passing to it. That means our pointer must be pointing to a parentheses. It should be. That's what the grammar says. And if it doesn't, we need to throw an error. We can do that by consuming opening parentheses. And we can copy that from here. and I will change that to while. We expect an opening parenthesis after while, and we also expect a right parenthesis afterwards somewhere uh, after condition. In the middle of these we have an expression that is the condition of the while loop. Condition, expression, and after the expression we have the body of the while loop. Now the body of the while loop may be a print or an if or a nested loop, or it may be a variable declaration, and it cannot be a variable declaration, it has to be a block, and all of these are actually handled in the statement block. So all of these cases right now are handled right here, as you can see. If we see a left brace, we parse a block. If we see an if, we parse an if we see print, we parse a print. So for the body of the while loop, all we need to do is call that statement method. Statement, that'll be the body of the while loop statement, and all we need to do is return a new while. Inside of this while, I'll pass it the condition and the body. Now since we added it to our statement visitor, we also need to add it to our interpreter, implement it in the interpreter. Let's go and implement it. Inside of the interpreter, let me call it stmt, and this method will be reused for a while loop as well, because when we are parsing a while, when we are parsing, I'm sorry, this method right here which we are implementing will be reused for a for loop as well, because when we are parsing a for loop, we will convert it into a while statement. So that this method is the only thing we will need to add to our interpreter for both of these loops. Okay, so stmt dot condition, we have something in the condition, right? We can evaluate its value like so. Now this value may be truthy or falsy, and our while loop actually depends on it. So let me actually calculate that. So is truthy returns, what does is truthy return for me? Is truthy, we already have this method that checks truthy values and logs. This returns a boolean to me. Boolean condition equal to, and while, so we probably need to recalculate it again and again. So instead of creating a variable, just put it right here. And like an if statement, we will also evaluate the while loop to the resultant of the last expression of the block, and that we will handle similarly like we did in if. So while is truthy, the condition inside of here, the result will be equal to statement dot body dot accept of this, and all we need to do here is return this result. So I guess this should work for a while loop. Let us see if it does. Let's copy this, paste it. Does it work? It does work. But like I told you, we will add other things to our code as well. We need to add, according to the changes, we need to add a for loop, we need to add break statements and continue statements. So before implementing the for loop, let us implement the break and continue, because they are simpler than a for. So we need to create two more objects in statement that are going to be break, and it needs to extend statement. Now the only thing inside of the break is going to be a token that will be the keyword that marked the break. So public token, let's just call it token. and public it's going to be final. Let's create this constructor and implement the methods, and inside of here I will call the visitor dot visit break statement, and I'll call it with this. And similarly I want to create a continue as well. Continue. It's going to be essentially the same thing, but instead of that break it will be a continue, and instead of break we will call continue statement, and we need to create this method. And now let's come to parsing these continues and breaks. In the parser, these will be handled in the statements, so we need to add them to our statement as well. What token marks them? So a break is marked by the break token, and a continue should be marked by the continue token. So in case it is continue, we will parse the continue statement, and in case of break, we will parse the break statement and create break statement in parser, and create continue statement in parser. So the continue state, we need so these classes breaks and continues have a token in them. Now that token is already consumed in the parser. When we match the current token, it's already consumed. We can get it through the previous method. Token is equals to previous, and a continue statement must necessarily be followed by a semicolon, and we can check for it and throw an error using the consume method. And if the control comes here, there was a semicolon and it was consumed successfully. If that is the case, I can create an object of continue and return it. Similarly, for break, I will create the object of break instead. And now we need to add them to our interpreter. Those are two statements that we need to add. Visit and break. Now, how do you stop the control flow of a while loop when we encounter a break statement? We are implementing all of this in Java, right? And how can we break out of a loop? By throwing an error. So what we will do is, whenever we come to this method, we should throw an error, and that will be caught in our while loop. So whenever we break, I want to throw a new error, throw new break exception, and sorry, not return. I want to throw it. Throw, and similarly here, throw new continue exception. Now these classes don't exist yet. I will create it shortly. Break exception. It's going to be an exception. Continue exception. And these need to be empty. We are not doing anything with them. These exceptions are only being used to break control flow. So we don't need any message here. We will need an empty constructor, and we can do that, right? We need an empty constructor, and instead of passing in the message, we will pass everything null, comma, false, comma, false. Now, if you want to know what these parameters are, the message is null, the throwable is null. The enable suppression and writable stake trace, I am just keeping them as false. We need to do the same thing in the break statement as well. I don't know what these false are. I just saw that there are some in the superclass, there are some parameters that are Boolean, so I just gave them false. And we can remove this message here because we were using the empty constructors in our interpreter, and we need to call the super. So we're throwing exceptions. Now these exceptions need to be handled. Where will these exceptions be thrown? It will be thrown in a while loop. So all of this will be happening right here when we execute the body of the while loop. So there may be an exception here. So we can handle that like so. And we are throwing two exceptions and we will handle both of them separately. So if we happen to find a continue exception, in that case, we will just continue. And if we happen to find a break exception, in that case, we will break. Now let me test it. Let's try to test it. Let me break after it. So it will print only once. Previously it printed thrice, and then it should break. So let's see if it works. It does. So let me see if continue works. So if foo equal to 2, in that case we continue. Let's see if continue works. It does. For 2, yeah, it's not printing 3, right? So it continued after 2. Will it continue after 1? Oh, it never the control flow never stopped. Okay, yeah, so our continue is also working. Now the next thing we need to handle, so actually these challenges, the break and continue, are handled now. The next thing is, let me try to push it. Maybe we'll pass this while statements and then we'll do the for loop separately. Git add, git commit -n, while statements. Let's see if it works. Let's move on to for statements. So for statements, like I told you, when the only thing we need to do is when we need to parse a for statement, and then when we parse it, I will create an object of while. If you create an object of while, everything should work because our interpreter is already interpreting a while node of the AST. So all we need to do is implement the parser for it. Now this is the context-free grammar for. Let me go to the parser and for and for. Let me create this, and the context-free grammar that we need to parse is this. Now this parsing is going to be a little lengthy. It's not necessarily difficult. So we want to convert a for loop to a while loop. This is what a for loop looks like, and this is what a while loop looks like. It has something in it. So we want to convert this for loop into a while loop. We typically, if we do some pointer checks, we typically increment or decrement those pointers inside of the for loop, inside of the while loop, and those increment and decrements are written here, and this condition check is written here between the semicolons, and the initialization of I can be written here, but for the while loop it's written outside of the while loop. So like I told you, the initialization of the variable, it's written outside of the while loop, like so. Like so. We need to convert it, this to a for loop and maybe even I plus plus. We need to convert this. So we need to wrap all of this. What I mean by wrap is uh, we have a condition, we have an initializer, and we have an increment statement, and we have a body of the while loop, right? But the body of the for loop doesn't have the increment. So when we parse the body of the for loop, it won't have an increment inside of it. So the body of the for loop will just be a block or a statement. Let me. This will be the body of the for loop, right? But when wrapping it in a while loop, we need to wrap the increment operator inside of a block along with the body. So this will we will have an increment statement for the for loop, increment statement. So what we will do is we will create another block, and that block will wrap the body of the for loop and the increment statement in a block, and this block can be used as the body of the while loop. All right, so this will serve as the body of the while loop. And inside of a for loop we also have an initializer. Now the initializer sits outside of the while loop. We will have an initializer. It sits outside of the while loop, outside of the body of the while loop, and this while loop will have a condition here, right? So we will convert all of this into another block, like so. We will create a block. In that block, when we execute that block, the initializer will be executed once. Then it has a conditional expression. Now this conditional expression will be a while loop, and inside this, like I told you, this will be our while loop. So it's the same writing this is the same as writing this. So this will be our for loop. Our for loop is a block where the first thing that executes is the initializer, and then it's followed by a while loop. The while loop will have the increment statement that is typically part of the for loop right here, and it will be wrapped up in the body of the while loop alongside of it. This is what we will create. We will create a block statement. The block statement will have an initializer and a while loop. Now the body of the while loop will be so that it will keep the increment statement of the for loop inside of the body of the while loop. So the first thing we need to parse is the initializer inside of the while loop. We can remove all of this. The other thing is we need to check for an opening parentheses. So we expect this after a for, and like I told you, we will have a initializer. Right now, let's keep it null, and because the initializer may be null, it may be null in case our for loop looks like this, then some expression, and then some other expression. In that case, our initializer will be null. When will that case be? It will be when we match the current token to be a semicolon. The next token is a semicolon, in that case our initializer is null. But if the current token happens to be a var keyword, then we know there is some initializer. Else if we match the current token to be a var keyword, we will have some initializer and we can parse that initializer using the var declaration. We already have var declaration, we are parsing it. If we do not match a var keyword, then maybe we are just reassigning a value. And in that case, the initializer will simply be an expression statement. So else initializer is just an expression statement. Why expression statement? Because when parsing expression statement, it will also consume the semicolon for us. And similarly for var declaration, when we parse a var declaration, it will consume the semicolon for us. So the semicolon will have been consumed after this point. This consumes the semicolon, this consumes the semicolon, and this also consumes the semicolon. The next thing we have is the condition. Expression condition equals to null. And like I told you, the condition can be null, it's optional. So it will not be null if the current token is not a semicolon. So if not, check current type to be a semicolon. If it's not a semicolon, then we're going to have some condition. But if it's a semicolon, then the condition is going to be null. Condition equals to expression, and we expect to have a semicolon after this. So we are going to consume a semicolon, and in case we don't find a semicolon, we'll throw an error that we expect a semicolon after the loop condition. Now the third thing that is part of our for loop is the increment statement right here. So it's not actually a statement, it's an expression. It doesn't have a semicolon after it. So expression, incur expression, let's say it's null. It will not be null if the next token is not a right parenthesis. If it happens to be a right parenthesis, then our expression will be null. But if that is not the case, our expression will be something. We check the current type to be a right parenthesis, and if that is not the case, incur will be equal to some expression. And right here we expect there to be a right parenthesis. So we are going to consume a right parenthesis and throw an error in case the right parenthesis is not there. This consume method does that for us. The error is we expect a closing parenthesis after clauses. Now these errors that I'm throwing are all part of this syntactic error stage. So we will also pass this one as well right here. These errors are expected to be thrown, and this will be the error for us. Now, like I told you, we are going to create a block, and for the block is going to look like something like this. So this block is the body of the for loop, and we are enclosing the increment statement inside of a block. So we need to create that, but to create that we first need to consume the body of the for loop statement. Body will be a statement excuse me, it will be a statement. And if we only need to create this if increment statement is not null. So if incur is not equal to null, in that case body will be equal to a new block of, now this block takes a list of statements, right? So what I'll do is list.off, and inside of it the first thing I told you is the body of the for loop. So body comma the increment statement, like so. Sorry, the incur is an expression, not a statement, so I need to create a statement out of it. Control X, new expression statement, and I will pass it the increment expression. This creates the new body that is shown right here. And after this, I told you we need to create another block, and that block will have the initializer and then the body of the while loop. We need to have the initializer and then the body of the while loop. So also we only need to create this block in case initializer is not null, and in case the condition for the while loop happens to be null, we will create if it happens to be, if we don't happen to find a condition for the for loop, it's essentially calling a while, it's essentially like calling a while loop with a true. So I should actually keep it right here when we're consuming the condition. Where is the condition? Right here. So if condition happens to be null, in that case condition is going to be a new literal of true. All right, and we only need to create this block if initializer is not null. If initializer not equal to null, uh, in that case we need to create a new block. And this is the body of the while loop. So we created the body of the while loop, but we didn't create the while loop that includes the condition. So let me create the while loop first. So statement while is going to be a while loop is going to be a new while, and it's going to have the condition and the body we just parsed. So let me move it actually right here. This will be the while loop, and we will create a new block out of that while loop if the initializer is not null. So while equals to new while loop equals to a new block of, like previously, list.off, and inside of this I will pass in the initializer and the while statement, like so. And right here all we need to do is return this while loop, and I think that should work actually. Let me try to run it. It does work, so let's try and push it. So the tests pass. Let's check if we are throwing all the syntactic errors or not. Let's move on to the next stage. So all the tests work. All right, that's it for this video, and I'll see you guys in the next one.